Myself, Dr. R. Balamurugan, Associate Professor in the Department of Electrical Electronics Engineering, K.S. Rangasamy College of Technology, Tiruchengood. Inductive sensors are used for detecting the object. Let's see how the objects will be detected by using the inductive sensors, and what is the cross-section view and what are the operations of inductive sensors. Let's go into the topic. First of all, we will see about the introduction about the inductive sensors. So basically, a coil is used, which is nothing but an inductor, which produces a high frequency magnetic field. That high frequency magnetic field is focused towards a metal object, which is to be detected. So as a resulting, when this magnetic field is focused on that metal, it induces current in it. The current in turn produces a magnetic field, which will be opposite to that of the magnetic field which is produced by this sensor. So both the magnetic flux will be opposite in nature, and this magnetic field produced in the metal will affect the original cause of producing magnetic field, that is nothing but coil. So that makes the some signal changes, or we can say it as an inductance changes in that coil. By measuring the level of inductance in that coil, we can have the measurement of type of material and also the distance of metal which is present nearer to the sensor. Let's we have a cross-sectional view of the sensor, and we will go for the operation of it. So suppose if we are in need of multiple number of metals to be measured, we will go with multiple number of sensors. You can see here a metal is placed near an inductive coil. That inductive coil is connected with an oscillator and level detector, and which is connected with output switching. So this oscillator is mainly used for producing high frequency magnetic field with the help of this inductance coil. This inductive coil will focuses the magnetic field towards the metal, and the metal will in turn induce the eddy current. That eddy current will make the magnetic flux, which will be opposite to that of the flux which is produced by this inductive coil. This makes changes in the oscillator. When oscillator level changes, the signal oscillator will also get changes. That level which will be detected by using the output switching circuit, and the output given by this switching circuit will determine the type of object which is connected nearby the sensor, and the distance between the object is also get detected. Let's we have a cross-sectional view operation of this inductive sensor. You can see here, this is the cross-sectional view of the inductive sensor. The main part of this inductive sensor is nothing but a core, which is nothing but ferrite core, which is connected with an oscillator, which produces high frequency magnetic field. It is also connected with modulator, commit trigger, and then current driver, and it will be taken out through some cables. So the magnetic field will be focused towards the object through the magnetic core, which is nothing but ferrite core. The magnetic field will be produced by this oscillator. As I have already told, when this magnetic field is focused towards the metal object, that metal object will produce some current inside that. That current will make the metal object to produce the magnetic field, which will be opposite in nature towards the original cause, which is nothing but oscillator produced. That oscillator inductance level will get reduced because the magnetic field will get reduced because the magnetic field produced by this metal and the magnetic field produced by this oscillator will get opposite in nature. So what will happen means the oscillator signal level will get changes due to the opposite nature of the magnetic field. And when the signal level is changed, these measured with the help of commit trigger. The commit trigger will give the output with respect to the change in inductance level, and output will get amplified, and it will be measured at the outside to give the level of inductance present. By based on the inductance present, we can have a discussion that what type of metal is present outside that inductor sensor, and how much distance is also present. Like that we can define. So by using that, we can define which type of metal is outside the sensor which is focused, and we can also have the distance between the sensor and the device. So this is the operation. by the signal level change in the oscillator, we can have an output of schemic trigger level changes. And by measuring the schemic trigger output, we can have a measurement of the object and also the distance between the sensor and the object. That's all about the operation. Here, this oscillator will be having an LC resonance circuit to produce the magnetic alternating field, which will be focused towards that object through the help of the ferrite core. Thus, we can have an LC resonance circuit which focuses the magnetic field towards that object, and the object will get reflects the magnetic field after the eddy current induction inside it. So the magnetic interaction will make the measurement of inductance level. That inductance level will in turn give the measurement of type of object which is present towards the sensor and also distance between that object. So basically this inductive sensor is used for measuring the metallic objects, and it will not be used to measure the plastics because of induction of eddy currents will be done only inside the metal object. Next, we will go with the advantages and disadvantages of this inductive sensor. And another one main thing is it is focused towards the object by using the shield sensor. Suppose if there is no shield outside that coil means the magnetic field will be spreaded. So if there is unsealed sensors means it will not focus towards that object. If we are in need of focusing towards that metal object, we will go with the sealed sensors. Let's see the advantages and disadvantages right now. So basically, the main advantages is there will be no contact between the metal and the sensor. So here contactless detection is there, and environment adaptability is there because it will be resistant to all conditions in present in the industrial area such as dust and dirt, etc. And versatile metal sensing, high switching rate. There will be no moving part, so longer life. The main disadvantage is the average maximum detection range is 60 millimeter, and we can have only metal objects can be detected. We cannot have detection of plastic objects, and extreme temperature conditions will get affects the performance of sensor. This is the major disadvantage. Let's we go with an application of inductive sensors. Main application automated industrial processes, and we can have on military, robotics, rail, aerospace, and in medical field as MRIs image, that is magnetic resonance imaging, then production of transformer core and detecting the motion of or position of an object, metal objects, and traffic sensor moving of a car, and used in eye tracking and search coil production, machining procedures, metal detectors, automotive industries, like the application of metal detection, and then proximity inductive sensors will be going on. So thank you for listening. Thank you. So these are the references. Thank you. Thank you for listening.